Remember when we added and subtracted, right? See here, cos x plus y plus cos x minus y equal to 2 cos x cos y, right? If we reverse it, then it becomes as good as an identity. Similarly, here also, right? So this one and this one. Similarly, here, when we added and subtracted, this one and this one. So let's list down those identities as well. 2 cos x cos y is equal to cos x plus y plus cos x minus y minus 2 sin x sin y is equal to cos x plus y minus cos x minus y. Again, 2 sin x cos y is equal to sin x plus y plus sin x minus y. And finally, 2 cos x sin y is equal to sin x plus y minus sin x minus y. Okay, so this is part of the derivations of the previous identities. Now remember, how does this help? Right, this helps in you trying to find or solve equations. Okay, just to give you an example, let's say we want to find sine 15 degree, right? Now 15 degree is not a standard angle, but remember we can write it as 45 degree minus 30 degree, yes, or we can write it as 60 degree minus 45 degree. Now we can use one of the identities. Which identity? Sin x minus y. So sin x minus y is sin x cos y minus cos x sin y. Now these are standard angles. Sin 45 is 1 by root 2, cos 30 is root 3 by 2, minus again cos 45 is 1 by root 2 and sin 30 is 1 by 2. So root 3 by 2 root 2 minus 1 by 2 root 2. LCM 2 root 2 root 3 minus 1. Remember, you are not supposed to leave a root symbol in the denominator. So you are supposed to rationalize it. So root 3 minus 1 by 2 root 2 into root 2 by root 2, which gives you root 2 to root 3 minus 1 by root 2 into root 2 is 2, 2 into 2 is 4. Okay, you can take it one step further, saying root 6 minus root 2 by 4. Okay, so these identities helps a lot when you are solving problems like this. Instead of being given a numerical problem like this, we might be asked to prove that sin x plus y by sin x minus y equal to tan x plus tan y by tan x minus tan y. Don't panic. Just look at this: sin x plus y, sin x minus y. We know the identities for this. So sin x plus y is sin x cos y plus cos x sin y divided by sin x cos y minus cos x sin y. Now compare it with what we require. We require tan x. So which means we have to divide it by cos x, and to make this cos y disappear, we have to multiply it with cos y. So cos y gets disappeared, cancelled. Sin x by cos x will give you tan x. Now which means you have to divide all the other terms as well. Cos x, cos y, cos x, cos y, cos x, cos y. Now what happens? Cos y gets cancelled, cos x gets cancelled, cos y, cos x. So you're left with what? Sin x by cos x, which is tan x, plus sin y by cos y, which is tan y, sin x by cos x, which is tan x, minus sin y by cos y, which is tan y, which is what we needed. So nothing great. Okay, let me do one more and then we will close. Cos pi by 4 plus x plus cos pi by 4 minus x equal to root 2 cos x. We have to prove this. Yes, cos x plus y. Now cos x plus y is what? Cos x plus y is cos x cos y, cos x cos y minus sin x sin y. Right, this is the first term, plus cos x minus y. So cos x cos y plus sin x sin y. Right, now here x is what? So let's replace all the x with pi by 4. So pi by 4, pi by 4, pi by 4, pi by 4. Let's replace y by x. Cos x sin x and cos x. This is the second term. Now cos pi by 4 is what? Pi by 4 is 45. So cos 45 is how much? Cos 45 is, say you don't remember pi by 4, cos pi by 4, just I say short this one. This is 45 degree. That means this also has to be 45 degree, isn't it? That means both sine and cos will be same, and in the unit circle this will be 1, this will be 1, right? So this will be what? Root 2, 1 square plus 1 square, the whole root. So take any one of the angles. So it will be 1 by root 2. So 1 by root 2. I just want to show you, suddenly if you forget something, don't panic. Immediately you can figure out. 1 by root 2 cos x minus sin pi by 4 is also 1 by root 2 sin x plus cos pi by 4 1 by root 2 cos x plus 1 by root 2 sin x. Right, now this and this gets cancelled, plus and minus, and you end up with 2 cos x by root 2. Okay, Now again you have to rationalize the new denominator, root 2 by root 2, right? So now what happens? 2 root 2 cos x by 2. So this 2 gets cancelled and you're left with root 2 cos x. So not very difficult. Whenever you look at a problem, take a deep breath and try to understand what is being asked and how you can arrive. Okay, bye for now. Practice.